This video is all about Rolle Theorem and its applications. Let's review. When the function is continuous on a closed interval AB, remember that all the functions are continuous on their domains. If closed interval AB is a part of the domain of the function, then the function is continuous on the closed interval AB. When the function is differentiable on an open interval AB, function is differentiable on an open interval AB if first derivative is defined on the open interval. Rolle's theorem. Rolle's theorem, named after the French mathematician Michael Rolle, 1652 to 1719, provides conditions that guarantee the existence of an extreme value in the interior of a closed interval. Statement of Rolle's theorem. Let f be a function and AB is a closed interval and f is continuous on AB, f is differentiable in open interval AB, and f of A equals to f of B, then there is at least one number C in the open interval AB such that the first derivative evaluated at C is equal to 0. Remember that Rolle's theorem applies to f on the closed interval AB if all the three conditions in the Rolle's theorem are satisfied. If any of the conditions is not satisfied, then Rolle's theorem does not apply. So example 1, find the x-intercepts of the function f and show that f prime x equals 0 at some point between the two x-intercepts. F of x equal to x squared minus 8x plus 15. So let's find the x-intercepts. So set f of x equals 0. So you will have x squared minus 8x plus 15 equals 0. So let's try factoring. So looks like the factors are x minus 5 times x minus 3. Now we set each factor to 0. X minus 5 equals 0, then x equals to 5. X minus 3 equals 0, then x equals to 3. So let's list the x-intercepts from the smaller x value to larger x value. 3, 0 and 5, 0. So now we find the x value such that the first derivative is 0. So we start with f of x equal to x squared minus 8x plus 15. Now differentiate with respect to x. So the f of x becomes f prime x and x squared becomes 2x and 8x becomes 8 and 15 becomes 0. So now set the first derivative 0, which means we set 2x minus 8 equals 0. Now solve this for x. So move the minus 8 to the right, you have a 2x equals to 8, then divide the 2 and we get x equal to 8 over 2, which is 4. Now you can see the 4 is between 3 and 5. Example 2, verifying Rolle's theorem. Given f of x equal to x squared minus 8x plus 15. And I close interval 1 to 7. So number 1, let's check if f of x continues on this closed interval 1 to 7. Well, f of x is a polynomial, and polynomials is continuous. Polynomial function is continuous on this entire number line from minus infinity to infinity. And 1 to 7 is a part of this number line. So we can conclude that f of x is continuous on the closed interval 1 to 7. Number 2, is f of x differentiable on the open interval 1 to 7? Well, so let's first find the first derivative. And first derivative is 2x minus 8. And this is polynomial also. And this is defined on the entire number line from minus infinity to infinity. Same argument, 1 to 7 is a part of this one. So f of x is differentiable on the open interval 1 to 7. Okay, so now we're going to check if f1 equals to f7. So start with f of x and find f of 1. So f of 1 is 1 squared minus 8 times 1 plus 15. And that becomes 8. Now we find f of 7. 7 squared minus 8 times 7 plus 15. 49 minus 56 plus 15 is also 8. So clearly f1 equals to f of 7. So we already verified the function is continuous on the closed interval, a function is differentiable on the open interval, and now f1 equals to f of 7. So all the three conditions of Rolle's theorem are satisfied. So we can say yes, Rolle's theorem applies. Since Rolle's theorem can be applied, so find all the values of C in the open interval 1 to 7 guaranteed by the Rolle's theorem. That satisfies first derivative equal to 0. So we start with f of x equal to x squared minus 8x plus 15. We differentiate with respect to x. So f of x becomes f prime x squared becomes 2x, 8x becomes 8, 15 becomes 0. We set this to 0. Move the 8 to the right, divide by 2. So it gives the x equal to 4. Now 4 is in the open interval, 1 to 7. So C is equal to 4. So example 3, we have given f of x equal to x plus 2 or x minus 1 and the closed interval negative 2. So we're going to determine whether Rolle's theorem can be applied to f on this closed interval minus 2. If Rolle's theorem cannot be applied, explain why not. B, if Rolle's theorem can be applied, find all values C in the open interval minus 2 to 2. So let's start with this function and check if this is continuous. Well, you can see that if I substitute x1 here, the denominator becomes 0. So anything divided by 0 becomes undefined. So you can see f of x is undefined at x equal to 1. So we can say f of x is not continuous at x equal to 1. And now we have to check if 1 is in interval. And if 1 is in interval. So therefore f of x not continuous on the closed interval minus 2 to 2. So we stop here and we say no, Rolle's theorem cannot be applied because f of x is not continuous on the closed interval. So if Rolle theorem can be applied, find all values C in the open interval minus 2 to 2. Well, in part way we concluded that Rolle's theorem cannot be applied. So the answer is NA. Alright, we have a function f of x equal to 2x minus 3 times x to the 2/3 and the closed interval negative 1 to 3. So we're going to determine whether the Rolle theorem can be applied to this f function on the closed interval negative 1 to 3. So if Rolle theorem cannot be applied, x and y not. B part, if Rolle theorem can be applied, find all values of C in the open interval negative 1 to 3. So number one, let's check if f of x is continuous on this closed interval. Now you can see the f of x behaves like basically polynomial. It's not polynomial, but it behaves like polynomial. So it's defined for all real numbers in this interval from minus 7 to infinity. So we can say f of x is continuous on this interval. And now minus 1 comma 3 closed interval is a part of this one. So we can say f of x is also continuous on the closed interval minus 1 to 3. So now we're going to verify if the function is differentiable on the open interval from minus 1 to 3. So the f of x is 2x minus 3 times x to the 2/3. So f of x becomes f prime x, 2x becomes 2 times 1. And power rule says 3 and bring the power down 2/3, multiply with the 3 and subtract 1, 2, 3. Now we simplify. 2 times 1 is 2, 3 times 2 third will be 3 cancel gives you 2, and 2 third minus 1 is minus 1 third. Now we can rewrite, we got 2 minus 3 over x to the 1 third. We can need to combine single fraction, so we can multiply 2 with x to the 1 third and divide by x to the 1 third. So now we have the same denominators. We write the denominator once, we subtract the numerators. So we got this fraction. And now you can see, okay, this fraction is undefined when x equal to what? 0. Okay, the denominator x to the 1 third, let's set to 0. And so we can solve, we can get x equal to 0. Now f prime x is undefined at x to 0 because if I substitute 0, it becomes 2 times 0 to the 1 third minus 3. 0 to the 1 third equal to minus 3 over 0, which is minus infinity. Since 0 is between negative 1 and 3, so f of x is not differentiable on the open interval minus 1 to 3. So we stop here. Okay, we say Rolle theorem cannot be applied. And since Rolle theorem cannot be applied, the answer to part B is there is no value c in the interval negative 1, 3 where f first prime c equals to 0. So the answer is not an A. So example 5, application of Rolle theorem. We have a height of ball t seconds after it is thrown upward from a height of 6 feet and with initial velocity of 48 feet per second, and that's given by the equation f of t equals to minus 16t squared plus 48t plus 6. So let's verify f1 is equal to f2. Wow. So substitute f1 is negative 16 times 1 squared plus 48 times 1 plus 6. Minus 16 plus 48 plus 6 will become 38. Now we find out f of 2. So minus 16 times 2 squared plus 48 times 2 plus 6. So that will be 2 squared is 4 minus 64. 48 times is 96 and plus. Now we put in the calculator, give 38. So you can say clearly, yes, f1 equals to what? F of 2. So the next question, according to Rolle theorem, what must be the velocity be at some time in interval 1 to 2? Find the time. So let's see, you start with f of t and differentiate. So f of t becomes f prime t. This becomes minus 16 times 2t and plus 48 times 1 and 6 becomes 0. And now we simplify the negative 32t plus 48. Set this equal to 0. Move the 48 to the right, divide by negative 32, simplify, gives you 3 over 2, which is 1.5. So 1.5 is in the interval, so the answer is 1.5 seconds.